1997 Dodge Neon with a 2.0 liter engine, and it's a no start. History with the vehicle: it just had a transmission replaced here at the school, and first thing we're going to do is we're going to check it for spark. So we're just taking a test light, connected to battery ground, and we're going to crank the engine over and pull one of the plug wires off. There are 2 coil packs on this design. We're just going to pull one plug wire off, see if we have spark. Josh, can you crank that for me, please? 1 second. Go ahead, take that plug wire off. Give me a little bit of an air gap so I can see it on the camera. That's good. All right, crank that, Josh. Okay, as you can see, we have no spark, so we're going to start chasing this for a no spark problem. Okay, next step is to check the trouble codes, and you can see we have a PO320, no crank reference signal at the PCM. Obviously that's going to cause a no spark situation, so we have an input problem. There's also a torque converter clutch solenoid code. I'll have to let our trainee guys know that that code is there. Maybe we can address that for them too, but we're attacking the no spark situation right now. And the next thing we'll do is we'll look at some ScannerDanner PIDs. Alright, so we pulled up cam and crank sensor data PIDs on this car. This is unique to Chrysler, having both of these, and notice they both say no right now. And the whole time you crank the engine over, they should both say yes. You can also look at the RPM too if you want to, but for what we're doing right now, cam and crank data PIDs are ideal. Go ahead and crank it. Keep cranking it. Keep cranking. Okay, good. Notice the cam sensor said yes, the crank sensor stayed no, so that's a good indication that you have a crank sensor problem, as our trouble code indicated to us. But I want to warn you guys that sometimes these can misidentify which sensor's faulty. We could actually have a cam sensor fault and have a good crank sensor and have the opposite trouble code. So just be careful with that with Chrysler. Here's what we know though for sure, is we have an input problem, and that's where you're at with this test. Make sure they both say yes the whole time you're cranking. You saw the crank sensor said no, so we're going to go after the crank sensor for sure first. If we have a good crank signal, we'll also check the cam signal. The next thing I want to show is a bidirectional control to fire these coils and see if we can make this thing spark. So we're going to do that next. Okay, so we're going to do a functional test now. Go ahead and hit the functional test tab, and we're going to do ATM test, which is actuator test mode. And under our actuators, we're going to find our ignition coils. Don't hit it yet. Ignition coil 1, ignition coil 2, and we're going to do those individually. And what we're going to do, go ahead and hit ignition coil 1. What we're going to do, don't turn it on yet because we got to get set up out here. At the top of the screen, let me get you up there. You'll see that it says on and off. We're not really worried about data PIDs for this test. None of these PIDs really matter to us. All we're going to do is turn on the ignition coil number 1 while we're set up under the hood with our test light with an air gap. See if this coil number 1 fires, and then we'll do the same thing with coil number 2. Going back under the hood. Alright, so we're back under the hood, and there's 2 different coils on this. Even though there's 4 coil wires, there's 2 different coils. Coil number 1, go ahead and point to it. That one is cylinders 1 and 4, and then coil number 2 is cylinders 2 and 3. So we're just taking one plug wire off coil number 1, and we're going to see if we have spark, and we're going to use the scan tool to fire the coil. This is again unique to Chrysler. Very nice bidirectional control. Go ahead and put your test light in there. Give me a little air gap, and go ahead and turn that on. And slowly pull it away and see what kind of arc it jumps. We should get at least a ½ an inch or more arc. That's very nice. Hold it right there. Okay, cool. Go ahead and turn that coil off. Put the plug wire back on. Let's go to coil number 2 now. Keeping in mind, we had no spark during cranking, and now we do. Go ahead and turn coil 2 on. Very nice. Alright, go ahead and turn it off. Alright, so we already know this that we have an input problem. But this confirms that it's an input problem. The computer is able to control the coil. The computer wiring is good from the computer to the coil, so it's not an output issue. The computer has control of these coils. The problem is you have an input problem. So to review that, if you have no spark, you crank the engine over, but you can command the coil to fire with a bidirectional control, you have an input problem. And that's what our trouble code told us, and that's what our cam and crank data PIDs told us. We have an input problem. Going to the crank sensor next. Okay, so we're going to do a cam and crank measurement using my picoscope. And I'm cheating a little bit here. I've been here a million times with the 4-cylinder Chryslers, and actually I think it's the same on the V6 engines too, but it's the end of this connector right here, and we're looking at a tan with a yellow and a gray wire, and that is your cam and crank inputs that come into the computer. The reason I'm doing it up here first is it's just difficult to get underneath the car to do the measurement, so I'm going to measure it right here at the computer first. And so 2 channels, 1 to each wire, and my scope ground is connected to battery ground. And we do have a charger on here, so we will have a little bit of interference from that possibly, but if we see some noise in the picture, that's what it's coming from. Alright, so we got the screen set up, we have the Pico set up, 2 channels. Channel A is on a plus or minus 10 volt, channel B on a plus or minus 10 volt, and time base of 100 milliseconds per division. And all of these settings are going to vary depending on the vehicle that you're working on. It helps to know a little bit what you're doing. And this particular car is a Hall effect. It's a 0 to 5 volt square wave, and you would set your scales accordingly with that. So we're going to crank it, so we need a little bit longer time base on a crank because there's less rotations, obviously. This should be a pretty good picture. My blue trace is my cam signal, my red trace is my crank signal. Go ahead and crank it for me. Okay. So as you can see, we have a cam signal, we're missing our crank. We can make the picture a little bit more clear if I use the sensor ground, or I can turn my sampling down, or I can put a filter in there, and we can clean that up a little bit. So that's with the little filter added, and you can do that after you store the waveform, which is kind of nice. So there's your cam signal, and there's your crank. Crank is obviously missing, so our scan data was correct. Our PO was it 320? PO 320 trouble code was accurate, and it was in fact a crank sensor problem. A little bit about this sensor is this is a pull down type switch input. If you guys remember from section 2 in my book, we talked about pull up and pull down circuitry. And Chryslers, all of their Hall effects use a pull down design. So this crank sensor signal wire being at 5 volts tells me that the computer is sending out the signal that it needs to. The crank sensor is supposed to pull it to ground to make the square wave. So this being at 5 volts tells me I don't have a short to ground in the harness, but I potentially have an open or a faulty sensor, so we need to go to the sensor now, check powers, check grounds, check the signal. One thing I can tell you on this design for sure is there's not going to be a signal at the sensor either. There are some design Hall effects that you can have a no signal at the computer and a good signal at the sensor, and that'd be on a pull up design. That's not possible on this design. Computer sends 5 volts to the sensor, sensor pulls it to ground to make the square wave. Pull down design, fixed 5 volts here. We're not going to have a signal at the crank sensor. That's where we're going next. Okay, we're underneath the car, right by the oil filter. Right above the oil filter is the crank sensor. And as we were moving the tape so we could access the wiring, so we could piggyback this and get some readings, these wires for the crank sensor pretty much just pulled off. Now, that probably is our problem. We're not 100% sure because You know, these wires are pretty brittle. They sit right below the exhaust manifold. Everything's pretty hot. But at this point, for what we have, we really don't have a choice but to fix the wires first and then see what we got and go from there. There's really no point for me to check the power and ground to the sensor because they're broken. This would be, the orange wire would be your 5-volt reference or power feed for the Hall effect. It's a 5-volt power feed for this one. And the black with a blue stripe is your sensor ground. We did check this wire. We do have 5 volts on it. We're gonna fix these wires and see what happens. Okay, while I'm here, I'm gonna show you guys how to fix a connector like this. And I wanna work with these 2 broken wires on the workbench. This gray wire I wanna pop out of this connector. To do that, you have to get this blue locking tab off on the inside so we can get to the release points of the terminals. And so the first thing is to do that, and I'm gonna try to keep my hand out of the way so you can see what I'm doing. Let me get set up here, and I'm gonna push on the inside. I don't know if you saw how I did that. I went through the inside of the connector, popped this blue plastic piece out of the way, and once this guy's out, then what we can do, you got a shot of that? Then what we can do is we can go inside of this and we can pop these 2 clips out of here. Actually, the one I want to get out right now is this gray wire. So I don't know if my pocket screwdriver is going to be enough. There's a T-pin. Can you see in this area where I'm at, Kenny? Are we okay? Mm-hmm. So I'm going to take this T-pin and I'm going to pop up on the release clip, being gentle that I don't break it. I don't know if I can show this at the same time, but once I release that, then I'm going to pull the connector, and you should be able to see that pulling right out of there. There she is. There's our gray wire. We're going to use that one. Let's see if we get a shot on that. We're going to check this and make sure these aren't, this one isn't broken too. I don't like the way this looks. Just going to pull on it and make sure it's okay. Okay. All right, I'm happy with the gray wire. We got to fix those 2, but we're going to go back up on my table and we're going to work with this connector first. Pause it. All right, so now I got this connector up on my desk, and the next thing we're going to do, we're going to pop these other 2 terminals out of here. And there's your plastic release clip. So you push up on that, and at the same time you're pushing up on that, you got to push down on the metal terminal. And I'm not sure I'm going to be able to show that. My fingers are probably going to be in the way, but I'll try. So I'm using my pocket screwdriver, and little things like this are tough to film. Prying up on that, push the terminal, I got it. Go on the back side now, and one of the things we definitely don't want to do is we don't want to mix this up, right? If we mix these up, this sensor's not going to work. And we could damage the sensor. So this is my sensor ground wire, is black with a blue. Remember that that's in the middle, okay? And that my gray wire that we took out, so let's look at the locking tab. So our locking tab is here on the front face, so our gray wire that we pulled out of the car would be the one to the right. So we don't want to mix up the gray, which is my signal wire, and the orange, which is my sensor power feed, or the 5-volt reference that supplies power to this sensor. So we definitely don't want to mix those up. And then one more, get our orange wire, so same thing, lift up on the tab, hold that up, push with your pocket screwdriver, whatever you have, and there's your orange wire. And now we can work with these. And what we're going to do is we're going to run some extension wires to these and work with it that way rather than putting new terminals in. I don't have these terminals. It would be ideal if we had a assortment of terminals sitting around, but in the aftermarket with what we do, we don't have that option. I can't have terminals for every different car. So you work at a dealership or whatever, you might have these laying around, or maybe you just put a whole connector in it. We don't have that luxury either. We need this car done. I need this car fixed, so we're going to do it. Okay, so the first thing we want to do is we want to save these pieces. I don't want to try to open this up. There's no way I will be able to save this terminal if I open this up and try to stuff a new wire in there. I have enough wire left here that I can use this, and one of the best ways to get insulation off of a wire is a lighter. I know this is not, you know, maybe the preferred method, but this is going to soften up that insulation very well. Obviously, you need to have a little bit tough skin here, but you see I pulled that insulation off, no problem. And I got a lot of copper wire here that I can deal with, so I have enough that I can solder to. Little trick of the trade there. So same thing with this one. Let's get this insulation off of here. And I don't want to mess this wire up. So the reason I'm not using wire strippers is you have a tendency to cut or break wire if you don't do it right. So I'm just going to heat it using the lighter and hopefully not burn myself. And there you go. We got plenty of wire to work with this one too. And we'll take a pair of dikes and just snip the end of that one off. We want this to be clean looking too. So we'll snip that out of the picture. And now we got something to work with. Alright, obviously there's a lot of different ways to solder. This is just the way I do it. So I'm not saying that this is the way to do it, but everybody has their own technique. But the first thing I want to do is I'm gonna mesh these two together. So these are smooth, they're not twisted up. We're gonna mesh these two together. And then we're going to hold the ends and we're gonna spin it. And so before we solder this, because we want this to be pretty clean, is we want to have a nice area with no big bumps or fat spots in it that are gonna make my heat shrink have an issue going back into this connector. So using a butane soldering gun, very nice little snap-on tool here. Love my butane soldering gun. I don't know what I'd do without it. Alright, so obviously we need to wait till the gun gets hot. A little trick of the trade for soldering is put a little bit of solder on the tip of the gun, and what that leaves is a little puddle that'll help the heat transfer into this wire a lot faster. And I'll generally feed some solder in between the gun and the wire first, and again, it helps in that heat transfer. And it still isn't hot enough. Some pretty crappy solder too. You see that little flick I gave it to at the end, and what that kind of does is it gets any of the additional solder off of that. A little bit on the gun, we'll get rid of that. And we want this to be smooth. I don't want any hard or sharp parts for my heat shrink. So now that's one. Got a piece of heat shrink, and we'll cut a piece of that. Feed that into here. And again, this has to go inside that connector, so I don't want to go all the way up into the metal. I just want to go right to the end, and we're going to use the gun itself to shrink this. This little hole in the butane gun works perfect for that. And this isn't really the best heat shrink. They make some heat shrink that has a kind of a resin inside of it that really seals them up very, very nicely. But this is the best we got right now. It's going to be better than electrical tape for sure. And that would be one. We do the same thing with the other one. So again, we'll mesh the two together. Making sure this is very tight before we try to solder it. Feeding solder between the wire and the gun first. Build that kind of puddle around it. Helps with the heat transfer. Some guys will use a flux, which helps for that too. To each his own. Just make sure that it goes all the way through. I'm putting the solder on top of the wire, letting it run down, and that's the second one. Same thing, cut a piece of heat shrink. Putting this at the end, or close to it. This heat shrink's just a little bit big for this application. It would have been nice to have a little bit smaller one, but there's our two wires. Next thing we're going to do is put them back in the connector. Okay, so we're going to put these back in the connector. I know one thing for sure, that my middle one was my ground, and so I did pick some colors from just a bunch of wires I have laying around. I'm using an orange and I'm using a blue. Our blue will be our blue-black when we put it on the car, and that was definitely the middle one, so we'll put that one in first. And going from the back side, making sure you're the right direction. On this one, I think it'll actually go in either way, and that's really not critical. Push that in until it locks, until you feel it snap. And that is locked into place. So that's one. And when we pull this apart, I said I think bottom right, when we were looking at the locking tab, our bottom right was our gray wire that we pulled out of the car. Is that right? Yeah. Okay. So our bottom left is going to be my orange wire. And same thing, I'm going to put it in the same direction. And again, I think it doesn't really matter on this one. I think it'll go either way. That locked into place. There's our extension piece we're going to use. Our blue clip, we can't put that back in until we go back to the car. What we'll do when we get underneath the car is I can trim these back, and this is where we'll do our soldering under the car. We got a lot of extra wire to work with, makes it a lot easier. We're done. We did the hard stuff up here on the bench, and now we'll go back to the car. This is pretty typical, or pretty standard way that I will fix connectors when the wires are broken right at the connector itself, is doing it like this. Okay, I didn't show the rest of the soldering. It's just pretty straightforward, and this video is going to be too long as it is. So I finished soldering those up, used some heat shrink. Of course, the two wires that I fixed are a little bit longer than the existing wire that was in the harness, but no big deal. We just got a little bit of extra slack in the harness, and I used heat shrink on the other side of it too. And I did notice there was some oil inside the connector for the crank sensor. However, there is an oil leak above it, so I'm not sure that's coming from the inside of the sensor. If it is, that's an indication that this sensor is going to need to be replaced. And again, we don't know if this car is going to start or not, because just getting down here and moving the harness is when these wires broke. So pretty sure that fixed it, but if the car doesn't start, we'll finish our crank sensor tests. If it does start, I'll show you what a known good waveform looks like. Okay, so we're all wrapped up. We have the wiring for the crank sensor repaired, and this will be our first crank. I have the scope back up so we can take a look at the waveform, and you can see something different right away. Before, we had 5 volts on the blue trace, which is our cam, and we have 5 volts on the red trace, which is our crank, and now we're at 0, and that's a good indication that this crank sensor is now working. And dependent on where that crank stops in position, that signal is either going to be high or low. So it's normal to be fixed low with just a key on, dependent on crank position. Go ahead and crank it, see what happens. Crank sensor signal, cam sensor signal, got a little bit of noise in the picture. We could use the sensor ground to clean that up a little bit. Again, I can put filters in here too. We can freeze that capture. Go ahead and shut that off for a second. And you know, we can throw a filter in there to clean that up a little bit. So it is a little bit choppy, but that's really not a big deal. But what we can do with this waveform, we can save this waveform now and call this you know, known good cam-crank relationship, and at a later point in time we can go in and we can look at that in a zoomed level, and you can really get some detail on cam and crank position and all that. But that's really not important for this. That's a fix for sure. Broken wire to the crank sensor. I want to show you one last thing, and that is the cam and crank data PIDs we used before during cranking to tell if this thing had an input problem or not. What I'm going to do is disable the ignition. I'll unplug the coil. We'll crank it over. We'll look at those data PIDs and show you what they should look like during a crank. Okay, again, looking at the cam crank data PIDs for yes and no, and go ahead and crank it. These should both say yes the whole time we're cranking. Keep cranking. All right, that's good. So as you can see, the whole time we were cranking, they both said yes. There are some variables again to these signals. For more information on this, you guys can refer to section 21, which is ignition system inputs, in my book, and also I believe it's section 22, no start, no spark diagnosis, which gets into all this stuff and all the variables. But that's it. Neon with a broken wire to the crankshaft position sensor.